Okay, so not what this is all about, but this is generally what we're getting to, like we're doing a belt drive. We want to transmit power from a driving to driven. So what does all that mean, and why would we do it? Why are there different sizes? Well, we use those different sizes in order to be able to achieve a specific revolutions per minute here. The revolutions per minute over here are usually industry standards. This one happens to be 1725. But maybe we don't want this shaft here to turn 1,725 RPM, and we want to transmit the power through the belt so we have some flexibility. Then what would we do? Oh, well, we would change the pulley size. Well, how could we figure out, what it's going to run? Well, math, right? Like that's what we use for virtually everything that we need to figure out. So we're going to do that in kind. But before we do that, I just want to show you a few things here. First of all, you really need to determine, hey, based upon this speed that I know off of my motor plate, how fast do I want this to turn? And then if we look at this configuration here, small on the driving, bigger on the driven, what do you think is going to happen? Take a second to think. Here's one way we can find out. This is at the top, right? This is down here at the bottom. So we're going to hold my finger right here at the bottom where it's at, and I'm going to make one full revolution with this. One full revolution. Look at where that is. This made one full revolution, that did not. So what does that tell us? Well, that tells us that this belt has to travel a lot farther around here for one revolution, and that means that this is actually going to go slower. So small driving pulley, larger driven pulley means that the output is actually going to be slower. I'll get more torque, but I'm going to lose some speed. Okay, so a few things to remember right there. Now, how do I figure out what this is going to run, assuming that this is 1725? Well, that's pretty simple. We can do that. We can check this out. We're going to go here, measure. I got 4.5 inch pulley or sheave, and I got a 6.5 inch pulley or sheave. So I can simply just do the math. 4.5 divided by 6.5 is 0.6923. So if I'm at 1,725 RPMs here, I multiply that by 0.6923, and it's going to tell me what that's going to come out to be. Okay, so what we're going to do now is we're going to actually look and see what it means to measure it and make sure that our numbers are reasonably close. All right, first thing we're going to do, we're going to make sure that we put our safety guards in here. So we're going to put that on there. It may not necessarily be very clear, but please bear with me on that. Then we're going to go ahead and take the rest of the safety devices here now that I have no clutter, and we're going to remove the lockout tag out so that we can go ahead and energize the power on this. Set this off to the side. We're going to plug this in, and now we can actually turn this on and watch the belt drive go. Now, how we're going to be measuring the speed on this is with a tachometer. Okay, we got to make sure that the photo here is all the way over, and this is going to shine a light on this reflective surface, and it's going to pick up how many pulses it has as it's going around, and it's going to tell us what the RPM is. So let's do that real quick. So I have 1748. Now I told you this was a 1725. Well, I knew it was going to be different, just didn't know how much. So if we write that down, then what we can do is go over here and take that speed measurement and write it down, and what we can now do is figure out, hey, did we calculate and how close was it to input versus output? I'm interested to know what you end up getting or when you do this exercise, because sometimes there's some differences here. There's things that could happen that will make the ratio not as perfect as what you would find in a chain drive.